This presentation is of ongoing research exploring DAWs as a method to enhance teaching and learning. The main focus here is upon conceiving and designing complete pieces, stepping outside of the usual music production boundaries and into those of novel learning challenges and design-based thinking within the overall domain of sound-based music. Sound-based music treats sound as the basic musical unit rather than one based on the more traditional note-based paradigm, as Landy points out. But first, a short demonstration piece. So first of all, I would like to introduce you to what I see as three underpinning principles for this sort of work, both to inform the practice as well as the teaching of the practice. The first is the Japanese practice of Sawari. This is the self-imposed constraint operating as a useful obstacle where artificial inconvenience in creating sound produces the sound. The use of artificial inconvenience and/or constraint is present in any sound-based design approach once one moves away from the note-based paradigm. Second, Jamaican dub producer practices such as the use of effects with internally rooted feedback. From my perspective, not enough pedagogic focus has been made of the use of these sonic practices as a means of achieving novel versions. Whilst Eno describes these practices as raw, this is potentially a poor choice of descriptor both from a practice perspective as well as from a decolonial approach. Instead, they could be considered within Heidegger's formulations, of which two are perhaps instructive. The first of these is Erlebens, which is where the artwork becomes the object of experience and therefore an expression of human life. Secondly, that human action is understood and practiced as culture. So as an example, I would direct you towards Dennis Bovell's recent dub remix album of the post-punk group, The Pop Group, and their 1979 album Why, which Bovell also produced at that time. The third principle is that this work must also operate within a sense of the anti-aestheticist use of aesthetic materials. This is an approach that I've borrowed from Osborne, and I feel that this is folded into the development of these sound-based ideas. Example music styles that already do this include glitch, intentional live coding practices where the machine fails, or Eurorack modules which are deliberately starved of voltage supply. All of this is done to elicit new sound and behaviour, therefore highlighting deliberate practices in the search for new sound and experience. At the point where we transform a sound into something else, whether playing an instrument in an unconventional manner or sampling a vocal, degrading it, slowing it down, reversing it and distorting it, then we encounter this anti-aestheticist approach. If the goal is the new, then a direct consequence will be that beauty will be revealed in degradation, in artifacts, and in the odd boundary crossings between humans, objects, and machines. Let's listen to a recent example of this approach. So if you're watching this on YouTube, now is a good time to click the link in the description below to watch a little piece of a video with Skrillex, Diplo, and Justin Bieber. So if one accepts the anti-aestheticist use of aesthetic materials as necessary practice, then it follows that the various material forms, both raw and completed, will also expand. Sound-based music is just one of these material forms. I'm going to outline the demonstration piece and walk through its various parts. Additional examples are available on my YouTube channel and previously published work. The example can be divided into three component parts with a fourth optional performance element. A sound source, which I refer to as an excitor, individual channel effects as a part of the sound-based design, note, not sound design, send and return effects that also constitute a feedback network, and then an optional element is to devise some sort of performance interface. My preferred method is using the Lemur app by Line for iPad. An excitor is a means of agitating the feedback network. An excitor can be anything from an audio sample or samples, an instrument either played in real time or via MIDI, or, as used in this piece, a plugin that generates noise artifacts. In this sense, I used Ableton's vinyl plugin as a noise source, as it offers control over the density of scratches and therefore can go from none to full on. The exciter is a realization of both Sawari, in that it is an artificial inconvenience, that is, how does one make something musical from scratches and dust, and Osborne's anti-aestheticist use of aesthetic materials. As well as the vinyl plugin, the instrument channel also uses two resonators. My favorite approach when designing is to explore using resonators or modelers such as Ableton's Tension or Collision or similar from other manufacturers, or convolution, before making use of more traditional plugins such as EQs, filters and compressors. The resonators used in this piece allow the formation of a harmony generated from the clicks of the vinyl scratch plugin. It is, again, an artificially inconvenient method, but remember that the vinyl plugin allows for density and dispersion of clicks across a wide frequency spectrum, and that this is used to excite the resonators. Both resonators produce the following pitches shown on the right. So we can see the pitches here where we have C or 0 as the fundamental. We have the flattened third, E flat, so +3. We have the fifth, which is G, +7. We have the second or the ninth, depending on which way you want to look at it, as a +2, which gives us D. And then finally we have the flattened seventh, which I've placed a tone below the fundamental. So rather than having it as +10, I have it as -2. So resonator plugins are also a really good opportunity for production teaching to explore a large range of the compositional literature. Among these could include things like pandiatonic triads, as discussed by Persichetti, or those generated from pitch classes, or it could be those generated from serialist approaches, or even Stravinsky's tonal arrays. Both resonator plugins have a defined function while sharing the same pitch bases. The first resonator is used as a fixed source and therefore can be considered as the continuation of the exciter, converting its clicks and scratches into pitch data. The second resonator adds additional harmonizing of this pitch data. Lastly, both resonators have some modulation of their filter frequency by Ableton's LFO tool, which is left free running. The filter automatically sweeps any sound entering either resonator. The instrument channel also has 2 low-pass filters and, like the resonators, each filter has a specific relationship to the sound. The filters are important as they help to manage any unwanted frequency buildup. Filter 1 is also tied to an audio clip. It's a noise burst, so what happens here is that the clip automates the filter cutoff and resonance in a sweep from high to low, adding more spectral content into the piece. The second filter is switched in and out via the performance interface. This filter also has an LFO that is set to sample and hold, and this is also synced to the project tempo. So when the sequencer is running, this provides additional animation before passing on to the feedback network. So all of the plugins that I've described on the channel constitute the instrument, and then the signal is passed on to 3 send effects, and these are a reverb and 2 types of delay. It's important to note that the channel is set to effects only, so that none of the original signal is present in the final output. So these effects channels form what I refer to as an interconnected feedback network. Each effects channel is essentially sent to the others. So when we look at channel A, which is ambience or reverb, as well as sending to B and C, which are the delays, we also see that A, some of the portion of the signal coming in at A, is also sent back to the same channel. The next thing to note here is that also this audio 2 setting is set so that it sends the signal from each of these effects returns back to the original channel instrument. So thereby completing the process of this feedback network and looping effect here. And then just as a note, because you have to protect your ears, limiters are placed throughout this project. Most are set anywhere between -1 to -6 dB. Finally, these signals pass on to the master channel, which along with an EQ, which is used to identify dominant frequencies that can overpower the piece, consists of a number of effects to generate the final sound. These effects are a Soundtoys microshift, which is used to provide subtle shifting and doubling, the Eventide SP 2016 reverb, so this provides a small but reverberant room sound, and then finally the Valhalla Supermassive, which provides the long modulated reverb and tails. So finally, this is an illustration of the signal pathways. So we can see the clip and the exciter on the left feed into the instrument channel. The instrument channel then sends to all of the effects, and all of the effects also send to each other, and then they also send back to the instrument channel, and then finally that then goes back through to the master output. So this is the performance interface on the iPad. The interfaces that I tend to use range from like one big slider or button to multiple pages. I like the flexibility it provides, and I'm happy sacrificing touch sensitivity. The performance interface allows for sufficient control of key elements that produce the piece. So it's important to note that the piece is not produced just because I press play. You actually have to interact with it. The most important part of this interface is really the central section, which concerns the resonator. So I've got 5 buttons that essentially control the pitch states of the resonator. So they unmute and mute individual pitch channels, so you can create lots of different combinations. And then at the top right is a resonator mode button that essentially switches the mode between A and B. By controlling the individual pitches for the resonator, this allows for a number of pitch variations, which you can see here. So if they're all on, we have a C minor 9 stroke B flat. Whereas if we just have the C on, then we just have the fundamental. We can have the root in the 5th, the C add 5. We can have a minor triad, C flat G. We can have an E flat major triad, E flat G, B flat. We can also have a G minor triad with the G, the D and the B flat. Now this is just some of the available pitches, but there's a lot more that is possible. In terms of grouping controls, what I tend to do, rather than just have a bank of controls for one plugin, I tend to group controls together that seem to make sense in the way that they interact with each other across different plugins. So with this one, what we have here are basically a button to turn the vinyl plugin on and off. Then that's followed by a dial that essentially controls the density of the vinyl scratches. And then next to that is basically the decay control for the resonator. Now, these two controls interact with each other. In other words, the more dense the vinyl scratches, and if the resonator was up, then you'd get much more of this sort of unwanted kind of dominant frequencies being produced. So if the density is quite high, then the resonator decay will be quite low, and vice versa. This next set of controls are for the second filter. It basically consists of a button that turns it on and off, and a dial to sweep the filter. The next controls here are basically 2 buttons, the clip trigger and the clip stop, and then a dial for sweeping the filter and resonance. Now the thing about the clip trigger is that it starts the clip from the beginning, and that clip also contains automation of that filter. Clip trigger is important because until it started, for most of the piece, the sequencer is actually not playing. So it's really important to kind of grasp this concept that you can make sort of musical sounds or soundscapes with a DAW, but not necessarily have it playing. And this is really the advantage of things like this feedback network. So finally, we have controls for each individual effect, essentially is muting them in and out, and a stop button for the transport. So remember that when the piece starts, the transport isn't engaged until the clip trigger is engaged, and then the transport starts running. And then once the transport is running, filter number 2 will start to animate. And at any time, we can stop this animation, not just by turning the filter on and off, but also by disengaging the transport. There are some additional points to kind of note here. One of those is that if a piece can be derived from a DAW and the playhead is not moving, then this is also, in a very small way, part of Osborne's anti-aestheticist requirement. If a DAW is not playing and yet music can still be made, how does this change the way we perceive a DAW? So now we're going to discuss how we might extend the work. Whilst this sound-based music approach operates within already established domains, the design process should at once allow for both a piece or raw sources to be generated. Through continual interaction and performance, many other variant pieces could be derived. Whilst these are derived from the same system and, therefore, share similar sonic characteristics, yet they will also be demonstrably different. Whether this difference is minor or major is within the general control of the designer or producer. So, sorts of things that you can do are like changing the excitation source or changing the performance approach. As a matter of developing raw materials, any of these outputs can, instead of being pieces, also supply sample-based materials suitable for further manipulation and transformation. Whilst outside the scope of this current paper, even relatively straightforward transformations, such as pitch transposition or elongation applications, such as pull stretch, will provide new sonic material for incorporation in productions or as underbeds for sync opportunities. Now, whilst Ramirez and Rice refer to audio-based transformations, we can also convert the audio to MIDI data, which can also produce interesting results. So what you see here is the MIDI data generated from the audio in the first video example from the demonstration piece. So what I used was Ableton's audio to harmony algorithm to convert audio to MIDI. So now we're going to listen to several Ableton library instruments, which I've left at their default settings with no additional processing. And I've just identified little bits of the MIDI data for us to listen to. This is an Ableton instrument called drone tapes. This is a wavetable instrument called hang drum, and for this I've used an arpeggiator to convert the long notes into shorter rhythms, and I've also used a scale quantizer. For this one, I've taken the audio output from the wavetable synth that we've just listened to, the hang drum. So I've pitched it down by 24 semitones and doubled the tempo to 240 BPM. Then I've applied automation to the clip's transposition to generate this audio transformation. So let's have a listen to that. So this is the drone tapes example again. So instead of automating the clip, what I'm going to be doing here is essentially manually changing Ableton's algorithms in real time. For this example, I'm going to show you an idea using crossfading. So what I have here are a number of audio files generated from the MIDI data. The first time I run through it, you're going to hear it at the boundary crossings between each audio clip. So there's no crossfading between them. And then, by the magic of video, and then I crossfade them all so that you can hear the differences as they transition from one file to the next. So extending these working materials, it should be noted that everything that has been derived here is essentially from generating MIDI data. And the MIDI data comes from the audio file, not from a MIDI performance on a keyboard. This is less about the perfection of the transcription algorithm, but more about the algorithm's best guess of what the pitch is supposed to be. In this way, it is more in line with deliberate glitch practices and, again, adds to Osborne's anti-aestheticist use of aesthetic materials. So in essence, whilst we might well want to make a complete piece, that is, an object if you will, we might also make a thing. The thing can then be manipulated and transformed to produce new things. The demonstration at the beginning of this presentation achieves the following. It is a formal piece of work which can be listened to as a recording or watched as a live performance. It exists in a form, along with the Lemur interface, as a performable instrument. The project file is a research artifact that others could develop and build upon in ways that the fixed song or recorded artifact does not allow without some difficulty. If a group of students play or perform works realized during this type of teaching and learning activity, then this can be an event or exhibition and should be treated as such. The sorts of activities discussed here can assist courses and students in a number of areas. These include develop competencies in a number of skill areas, requires balance between technical and aesthetic requirements, provide students with opportunities to integrate a variety of flexible approaches in their work, encourages experimentation using familiar elements while stimulating divergent practice, develops a transformed thinking of their own discipline practices, and for educators, directs and expands pedagogy in both conceptual and experiential knowledge. As a closing thought, I feel that teaching work in this type of domain should always be oriented in favour of an aesthetic approach over the technical. This is because students will almost always require an antidote to an overly techno-rational discourse which music production is susceptible to. Thank you.